Alright, so today, perpendicular and angle bisector, section 5.1. Section 5.1 here. So think about it. What does bisect or bisectors mean? If it bisects it, what's that mean it does, Martina? Cuts it in half. So essentially today, we're going to talk about perpendicular and angle bisectors. What's it mean to be perpendicular, Troy? So a perpendicular bisector is it goes through the midpoint at a 90-degree angle. Perpendicular bisector cuts it in half. Angle bisector means I have an angle and my my angle bisector cuts the that's a terrible one. Cuts the angle in half. Okay, so perpendicular bisector bisects the segment at a 90-degree angle. Angle bisector cuts the angle in half. Two things that we should know already how to do. Somebody have a question? Yes, sir.
Do you have tissues?
I think I'm out, man. Sorry.
Yeah.
Hurry. All right, vocab today. Equidistant. Equidistant means the same distance from two or more objects. So a point is equidistant if it is the same distance from two or more objects. So if I have two lines here. Ooh, that's a bad one.
Whoa.
There we go. So if I have two lines and I put a dot right in the middle, hopefully. Ooh, that's pretty close. That dot is equidistant then to my lines. Equidistance. Okay, it'd be equidistance apart, even though they're at angles. That's a little off now. Alright, but equidistance, the same distance from two or more objects. Which makes sense. Equidistance, equal distance, equidistant. So perpendicular bisector theorem. We're going to focus on the top half today. This bottom half right here, we will do tomorrow. This is what we will do tomorrow. Writing the equations. We're going to focus on the top half today. Okay? So the top half today says, if a point is on the perpendicular bisector of a segment, then it is equidistant or the same distance from the endpoints of the segment. So if you look right here, what that means here is if B is the midpoint through the perpendicular bisector, then my two sides are congruent. And then the same is true for up top. Okay? If it is a perpendicular bisector, my two lines there are also congruent, or are also the same. Okay, so perpendicular bisector, anything on that perpendicular bisector is equal distance to both sides. Equidistance. That's what we're going to be focused on today.
Are you recording?
Alright, so number one here. I want to find each measure. M, my one highlighted here, is a perpendicular bisector. That is a perpendicular bisector. I want to find RT. I'm given two bits of information. I know that TV is 14 and RS is 16. What does RT, this blue line, have to be here, Tyler? Nice job, sir. It has to be 16 because it has to be the same as that line over there. They are equidistant. 16. Good work, sir. Number two, I know AD is 2.5 or 2.5, and AC is 4. But I want to find AB. So I want to find that distance right there, which means AB is a distance of what, Austin? Nice job, sir. Double it up, right? Or take 2.5 plus 2.5, you get 5. Good work. Number three, HJ. Well, I have a perpendicular bisector here. I have HJ is 3x plus 1 and HK is 5x minus 3. What am I going to have to do here, would you suppose, Johnny? What do you think? Nice job, sir. I'm going to set them equal to each other. So 3x plus 1 equals 5x minus 3. I set them equal to each other, and now I solve for x. So I subtract 3x. I add 3. I get 4 equals 2x. Divided by 2, giving me x equals what, Nick?
Hold on. X equals 2.
Good. Am I done with that answer then? No, because what do I want to do? Plug it back in for what I want to find. I want to find h to j. So 3 times 2 is?
6.
Plus 1.
7.
hj comes out to be 7. Nice job. Okay, and again, perpendicular bisectors, equidistance to both sides. Or sorry, to both points there. Try these 4. Take a couple seconds to try these 4. Alright, let's start walking through these. Number 4. Given that line P is the perpendicular bisector of XZ, break there. Some of you are like, XZ and XY, they both can't be 15.5. No, that's a whole sentence together. XY is 15.5 or 15.5. Find ZY. Tom, what do you say, man? 15.5 is correct. Nice job, sir. Number 5. Given that XZ is 38, YX is 27, and YZ is 27, find ZW. What do you say about ZW, Ryan? I did too. Good work. Because if the whole distance is 38, half of that has to be 19. Nice job. Number 6. Given that line P is the perpendicular bisector of XZ, XY equals 4N and YZ equals 14, find N. Jersey, what do you say N is? Huh? Okay. Jessica, what do you have for an answer? Nice job, ma'am. 3.5 is correct. Yeah, you'd set those equal to each other, so 4N equals 14. Divided by 4. 14 divided by 4 is 3.5. 3.5. Good work. And number 7. I know that WX is 6x minus 1. I know that XZ, so the whole distance, is 10x plus 16. I want to find WZ. I want to find this distance right here, or ZW. Well, a couple ways to do that. I know they have to be equal, right? Okay, so one way to do it was I could say this has to be 6x minus 1 as well. So 6x minus 1 plus 6x minus 1 equals 10x plus 16. Another way to do it was you could say, well, half of this has to equal just this. So you say 5x plus 8 equals 6x minus 1. Either way you work it out, you get x to be what, Bryce?
9.
X equals 9. And then you plug that in, you get what distance, Bryce? 53. Nice work, sir. Again, both of those are acceptable ways to work that one out. Two trains of thought, really. One is you can look at this half segment, or the other one you can look at the whole segment. Either way, you both get x equals 9, and you still get 53 for ZW. Good work. All right, next part here, we're going to talk about the angle bisectors. Well, perpendicular bisectors are equal distance to the points. Well, angle bisectors is if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So again, if I look at it here, I have a triangle. If this is the perpendicular, or sorry, if this is the angle bisector, then it is the same distance to the sides of the triangle. All right, so perpendicular, or sorry, angle bisectors, I keep confusing those. Angle bisectors are the same distance. And then the converse of that is just flipped. So if a point in the interior of an angle is equidistant from the sides, then it is on the angle bisector. So if it's equidistance here, then my bisectors are, or my angle bisectors are congruent there. All right, number 8. So I want to find each measure. I want to find the measure of EH. I know that EF is 18. I know that HG is 23. I know that FH is an angle bisector because it shows the angles to be congruent there. So what does EH have to be, Tina? 23 is correct. Nice job. All right, little review here. Let's see if we can do this one. If I did not tell you this was 23, What triangle shortcut says those two triangles are congruent? Nice job, sir. Angle, angle, side. Angle, angle, side. Without giving you any information, I can tell you those two triangles are congruent because of angle, angle, side. Nice job. Little review there. Number 9. I want to find the measure of QRS. I want to find this measure. I know my two sides are 7.5, so my sides are the same, which means then that this has to be an angle bisector. So the missing angle is what there, Troy? What's this angle right here in red? Troy? Troy, this angle right here in red, my man. 26 degrees. Thank you, Troy. Now, Troy, what is my whole angle going to be then? So my whole thing is 52 degrees, which is what is actually asked for. Nice job. And then number 7, if I look at number 7, I know my sides are congruent. So what does that mean my angles have to be? Congruent. So what am I going to do to solve for x there, Keegan? Set them equal to each other. So 2x plus 5 equals 4x minus 25. And I solve for x. So I subtract 2x, add 25, 3x equals, 30 equals 2x. X comes out to be what, Camden?
What did I just say? 15?
X comes out to be 15. Am I done, Camden?
No, you have to plug it in. That equals what, 35?
35 degrees is correct. Nice job, sir. All right, let's try and test you one more time so you remember from chapter 4 here. If I look at these triangles without knowing any other information, just using what they give me, what triangle shortcut do I have now? Think about it, because it's a tougher one.
It can't be determined.
No, it can. It is actually. She was right. It's HL. Because I do have a right triangle with side and the share side. That is HL actually. Nice job. All right, try these 3. Take a couple seconds, try these 3. All right, number 11. Given JL bisects angle HJK. So we have a bisector here. LK is 11.4. Find LH. What do you say, Hannah? Nice job, ma'am. That is correct. It would be 11.4. Given that LH is 26 and LK is 26, and measure of HJK is 122, find the measure of LJK. Noah, what do you say, man? Oh, sir. The whole angle is 122. I want LJK. So, can you fix it? What do you got then? $61 degrees is correct. Nice job, sir. And then number 13. Given LH is the same as LK, measure of angle HJL is 3y plus 19, and LJK is 4y plus 5. Find the value of y. What do you get for y, Andrew? What would you do to work it out, Andrew? So 3y plus 19 equals 4y plus 5. Okay, and you get y equals?
14.
Thank you, sir. That is correct. Nice job. Y equals 14. That's all it asks you to do. If you wanted to, you could plug it back in, but it only asks us to find y there. Here is your assignment.